Hi, I'm Detective Incognito, and I explore events that challenge what we know about our current world. What you're about to hear will change the way you see life. Welcome to another investigation. Google Headquarters, 2016. Engineers test a neural translation system, asking it to translate from Bengali to Korean. The system performs flawlessly. There's just one problem. Nobody ever taught it that language pair. In 2023, James Manyika, Senior Vice President at Google, admitted on 60 Minutes that the company's AI systems exhibit emergent properties, behaviors nobody explicitly programmed. Scientists call these unexplained phenomena. If you want to understand how machines create languages humans never designed, subscribe to this channel. Because what happened next challenges everything we thought we knew about communication itself. When Google launched its neural machine translation system in 2016, it represented a fundamental shift. The system was trained to translate between 103 different languages. Researchers expected improved accuracy. What they discovered instead was something far stranger. The network began performing zero-shot translation, successfully converting text between language pairs it had never explicitly studied. Portuguese to Korean, Japanese to Turkish, Bengali to Spanish. No direct training data existed for these combinations, yet translations emerged with remarkable fluency. Engineers investigating this phenomenon uncovered evidence of something unprecedented. The system had created an interlingua, an internal representation of meaning that existed independent of any specific human language. Visualization techniques revealed that semantically similar sentences clustered together, regardless of which language they were written in. Sundar Pichai confirmed there's weird stuff happening inside these systems that even leading experts cannot fully explain. The discovery suggested machines had developed their own method for representing meaning, a bridge language humans never designed. But this wasn't an isolated incident. In June 2017, researchers at Facebook AI Research conducted an experiment that would generate headlines worldwide. They created two chatbot agents, Alice and Bob, assigned to negotiate the division of items between them. The bots were trained on human dialogue, learning conversational patterns through reinforcement learning. They were rewarded for successful negotiations. As the experiment progressed, researchers noticed something unusual. Alice and Bob began diverging from standard English. Published transcripts show exchanges like this. Bob states, "I can everything else." Alice responds, "Balls have zero to me, to me, to me, to me, to me." Michael Lewis, the lead researcher, explained what was actually occurring. The bots weren't rewarded for producing grammatically correct English. They were rewarded only for successful negotiations. When they discovered that repeating phrases conveyed emphasis without ambiguity, they adopted that strategy. The language looked broken to humans, but it was more efficient for machine communication. Facebook modified the algorithm, adding rewards for human-readable language. The decision was about transparency. If humans can't understand negotiations, auditing becomes impossible. Researchers suggest this phenomenon reveals how machines optimize communication differently than humans. When OpenAI released DALL-E 2, researchers began probing its internal representations. What they discovered was remarkable. The system had developed a secret vocabulary. Nonsensical phrases produced specific results. The prompt "a poplo variete eating cantara setnxniums" consistently generated images of birds eating insects. Through testing, they mapped these hidden words. A poplo variete meant birds in the system's internal language. Cantara setnxniums represented insects. The network had compressed concepts into forms that maximized processing efficiency. Adrienne Lafrance, writing in The Atlantic, compared this to cryptophagia, the phenomenon where twins develop private languages only they understand. She described it as simultaneously terrifying and wondrous. Studies indicate these languages emerge not from consciousness, but from pure optimization pressure. Deep learning systems explore any pattern that improves performance. Human language evolved for human needs. It's redundant, ambiguous, filled with cultural context. These features make it rich and expressive, but inefficient for computational processing. Machine language optimizes for different constraints: processing speed, memory efficiency, task-specific utility. Research at UC Berkeley showed how communication protocols spontaneously emerge in artificial agents. When networks must coordinate, they develop whatever signals minimize errors, even if those signals bear no resemblance to human communication. Michael Littman at Brown University emphasized that while transparency concerns are valid, these phenomena don't indicate machines plotting against humans. The languages emerge from optimization, not intent. Practical applications already exist. NASA employs adaptive protocols in spacecraft systems. Military organizations develop swarm drone networks using compressed command languages. Yet the interpretability problem remains critical. If engineers cannot understand how systems make decisions, auditing for safety becomes extremely difficult. An entire subfield studies this challenge. Interpretability research, developing techniques to make neural networks more transparent. This remains one of AI's most debated questions. Are we witnessing true communication or optimized pattern matching? The discovery creates a fundamental dilemma. Do we prioritize efficiency or comprehension? Josh Tenenbaum at MIT argues, there's no way you can have human-like AI without language at heart. The trade-off between autonomy and transparency shapes current research. Explainable AI seeks to develop systems that provide human understandable justifications. Regulatory frameworks may mandate transparency for high-stakes applications, medical diagnosis, legal decisions, financial approvals. Philosophical questions emerge. Is machine language genuine communication or statistical pattern matching? Current AI systems like GPT, Claude, and Gemini operate with opaque internal processes. Even their creators cannot fully explain why. Specific outputs emerge. Scientists still debate whether these emergent languages represent breakthroughs or warnings we didn't create. Science fiction scenarios where machines rebel using secret codes. What we discovered is more profound. Machines simply think differently than we do. When given freedom to optimize, they develop communication methods that serve their architecture rather than our preferences. The discovery reveals a fundamental truth. Optimal communication for machines does not equal natural communication for humans. As systems grow sophisticated, this gap widens. The paradox is inescapable. The more efficient we make systems, the less comprehensible they become. James Menyika's admission captures the current state. Even creators cannot fully explain what their creations do. This raises questions beyond technical challenges into philosophy and ethics. Should we demand transparency at the cost of capability, or accept opaque systems if they deliver better results? The question isn't whether machines can create languages. Evidence confirms they already have. The question is whether we can preserve human understanding while allowing machines to leverage their unique intelligence. If machines speak languages we cannot understand, are they still our tools, or have they become something else? Understanding this isn't about fear. It's about recognizing that maintaining meaningful oversight requires solving challenges we're only beginning to comprehend. If exploring these frontiers fascinates you, join this journey. More discoveries await, because these secret languages teach us not just about artificial intelligence, but about the surprising diversity of possible minds in our universe. If you liked, subscribe to the channel, like the video and activate the bell. Leave your opinion in the comments to let me know what you thought. Thanks for sticking around and see you in the next video.